Okay, let's take a look at some more multiplying examples in this second video. Our first two I like because what you'll notice is it's the same two matrices but being multiplied in a different order, so that you can see how the answers will come out differently. So our first one here, we have a 1 by 2 matrix times a 2 by 1, which means we're going to get just a 1 by 1 matrix, or just one answer in here. Again, this inside number tells us we'll be adding two things in that spot. So we're going to do 2 times 5 first, and then go across and down to do -1 times 3, and get an answer of 7. We'll keep it in the matrix brackets. So now a 1 by 1 matrix. For this one, we have a 2 by 1, because we flipped the order, and a 1 by 2. So we will get a 2 by 2 matrix, and we're only going to be putting one number in each spot, so we won't have to do any adding for this one. So we'll start with 5 times 2, and it's actually almost like we're distributing the first row into the matrix across here. So I just wrote 5 instead of 10. Sorry about that. So we're going to get 10 and -5 for the first row. And then for the bottom, we're going to be distributing in the 3. So 3 times 2 and 3 times -1. This one's actually kind of a little easier to see because it looks like our basic distributing model. Okay, and the next one, although it looks very complicated, is even easier. Our first matrix is a 2 by 3. And our second has 1, 2, 3, 4 rows, so is a 4 by 2. My middle dimensions here don't match. So we can't multiply. And these are the least amount of work because all you have to do is write that this is undefined. Anytime you can't perform a matrix operation, whether it's adding, subtracting, or multiplying, you want to write that the operation is undefined. And then we have one more that's a little bit different, which is good, I think, to do one that's slightly different with some steps in it. This is a 2 by 3, and then 3 rows by 2 columns. So we can multiply, and we are going to get a 2 by 2 matrix that has 3 things being added in each spot. So we need a nice big one with a lot of space in those 2 rows and 2 columns. And I want to give myself room to add 3 things in each of my spots. So remember, row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. And that's where we're getting the results from when we're multiplying across and down. So I'll do the circling again. I'm not going to go through each number. I'll just talk through it. -1 times 1, -1 is 1. 4 times 3 is 12. Make sure to go across and down. And then -3 times -9, 27. And that rounds out the whole first space. So you're doing a lot of multiplying just for that one spot. And then we're going to go on to the second column, keeping the first row. Remember to go back to the left and to the top whenever you restart. So -1 times -2 is 2. 4 times 4 is 16. -3 times 10, -30. And then we'll erase both of those and go to our second row, back to the first column. 6 times -1 will be -6. -2 times 3, also -6. And then 2 times -9, -18. And then our last multiplying is going to be 6 times -2, -2 times 4, and 2 times 10. And our final result, when we add up our numbers, will be 40, -12, -30, and 0. And then we have a quick little application here. Just get rid of my circle so you can see it. And in fact, you could do this application without matrices, but we're going to set it up with matrices and do the multiplication from there as a way to organize our information. So you have a manufacturer that uses 4 different types of yarn: cotton, wool, polyester, and rayon. So probably what I'll do is abbreviate that C, W, P, and R just to label the matrix later on. You want to make 2 different blends of fabric, fabric A and fabric B. And then it tells us how much of each type of yarn is used for that fabric. The cotton yarn costs $4 per unit. Wool is $6, polyester is $2, and rayon is $5. So actually the first thing I'm going to have you write is a cost matrix, and we're actually going to write 2 versions of the cost matrix because you can write a vertical or horizontal, and depending on how you make your second matrix will depend on which option you want. So if I do cotton, wool, polyester, and rayon, and then put the costs in there of $4, $6, $2, and $5, or I can do it horizontally, 4, 6, 2, 5. Remember, with multiplying, our dimensions are going to need to match up. So one of these will work better than the other when we set up our second matrix. So the second part says write a matrix showing the number of units each yarn needed to do each type of fabric. So I'm going to do, just because of the space purposes, I'm going to do fabric A and fabric B here, and then I'll do cotton, wool, polyester, and rayon going across. But you could do a similar matrix and make it vertical, and that's going to then pick the correct matrix for part A. So let's go back to the sentence that says fabric A. We need 2 units of cotton, 6 units of wool, 4 of polyester, and 4 of rayon. And then 1 bolt of fabric B contains no cotton, so 0, 7 units of wool, 3 units polyester, and 6 units of rayon. So now we've used the matrix to organize our information. And I just want you to think about the size. This is a 4 by 1. This is a 1 by 4. And then this is a 2 by 4 matrix. In order to be able to multiply and get our dimensions to match, think for a second which matrix from part A are we going to need to use. And the one that we will need is the first one. Because if I put the fabric matrix first, and then I put my cost matrix second, by picking that first one, I get those middle dimensions to match up. And if I do the multiplying with this to give us a total cost of the yarn for each, we are going to get 2 different costs, a cost for fabric A and a cost for fabric B. I want to make that a little bit bigger because we're adding 4 things in each spot. So if we do our multiplying, we're going to get 8, 36, 8, and 20 for the first spot, and then 0, 42, 6, and 30 for the second spot. And this is something you probably could figure out, again, without setting it up in a matrix format, but this is just a different way to organize your information. So this is cost, fabric A, fabric B. So the total for fabric A would be $72 if you pull that information out. And then for the total cost, you'd have to take the 2 pieces of information out, add them together to get your total cost for both fabrics if you wanted 1 bolt of each. All right, that concludes our multiplying video. You now should take a look at the practice for multiplying matrices.